All right, so uh, in this video, we'll be looking at the trigonometry function of quadrantals. So let's consider when we say quadrantals, we're talking about the angles on the borderline. For example, like angle 90, 0 degree, 90 degree, 270 degrees, and 360 degrees. This is what we mean by quadrantals. So we want to see how we can find the trigonometry values of these angles. So here we'll consider a unit circle. When I say unit circle, I mean the radius here is equals to 1. So the radius is 1. So with radius 1, it means that also the distance from here to this point. So let's take a point on the circle. If you take a point on the circle, every point on it will have the x and y coordinates, right? Okay. So let's say here, so it means the distance from here to here is going to be our x, y, this is going to be our y, and we can have a 90 degree. And now what can we see from here? You can see that if we say here is theta, we can see that cosine of theta is going to be x over 1. So, and also sine theta is going to be y all over 1. And so what does that mean? It means that any point on this cycle, any point on this unit cycle, instead of x, we can replace x with what? We can replace x. So what it means is that what? Any point you have x and y can be written as the form of what? Cos theta, and y is what? Sine theta, right? So now remember, this is a unit circle. So it means the distance from here to this point is just x is 1, 0. Because you know the distance from the center also to the circumference is 1. And the y is 0. When you are down here, this will be what? The x here is what? 0, but the y is minus 1. When we are up here, what is x here? X is 0, y is 1. And when we're towards here, you will have that x is minus 1 and y is 0. Okay. Now, if we look at this point here, here we have theta. But by the time we get here, let's say this is a, let's explain it this way. You know, this point can be shifted. We can shift this point, we can shift it down. So if we shift it down, this will become our theta, right? So we can also shift it again until this terminal line becomes on the same line with what? With our x-axis. So in that case, theta will become 0, right? So it means when you are here, so this point is equivalent to cosine 0 and what? Sine 0. Because when you are here, when you bring this terminal down here, the theta becomes 0. So it simply means that if you compare this and this simply means that cosine 0 is 1 and sine 0 is what? It's 0. Also, we can see that this position is still equivalent to when the theta is 360. Because when it is 360, you have gone round. Yeah, we've gone round and back here. So we have 360 and also sine 360. So it means that what? Cosine 360 is also 1 because they are all in this position. Here we have 0 degree. Here we also have 360 degree for theta. Now, if we get up here, when you are up here, what will be your angle? Remember, this angle here is going to be 90. For example, is going to be 90. So at this point, theta is going to be 90. So it means this 0, 1 is equivalent to cosine 90 degree and what? Sine 90 degree. So you see cosine 90 degree is 0, sine 90 degree is 1. By the time we get here, this minus 1, 0 is equivalent to cosine 180 degree and sine what? 180 degree. So this tells us that what? Cosine 180 is minus 1, right? And what do we have here? Sine 180 is 0. So when we are here, if you get to this point, what do we have here? This is what? This is cosine. So here will be nothing but what? Cosine 270 and what? And sine 270 degree. Okay. So it means that cosine 270 is 0, while sine 270 is minus 1. So this is how to get the what's the trigonometric ratio of quadrantals. You can just use this one in a nutshell. This is what you should use. A unit circle. Here is which point? Here is the point 0, 1. Here is the point 1, 0. And here is the point minus 1, 0. And here is the point 0 and minus 1. Then you should use here as 0 degree or 360 degree, anyone. This at here, theta is going to be 90. When you are here, you use theta to be 180. And here, theta is what? 270 degrees. And you can always generate this trigonometry for quadrantals. All right, so let's answer some questions here. For example, example 6 here says find the exact value for each expression. So here is a 2 sec 0. Sec 0 is the reciprocal of cosine 0, right? And we know that cosine 0 is equals to 1. So this is just 2 times 1. Then plus, this will be 4. Cotan, this is like saying cotan 90 all squared. But we know that cotan 90 is what? Is the same thing as cosine of 90 over sine 90, right? And based on what we just discussed now, if you look at cosine 90, where is 90 degrees? This is 90 degrees. So cosine 90 is 0, while sine 90 is 1. So it means that this will be 0 over 1, which is equals to 0. So here we'll have 2 plus 4 times 0, right? Times 0 squared, which is just equals to 2. Then for the second one, B, here this is 2018. We know what to do. We can look for the coterminal if you like. This is 218. So if you're looking for 218 pi, you know this is greater than 2 pi, right? So we can just get the coterminal of this. And what will be the coterminal? You know, we'll subtract 2k pi, right? So we'll subtract k 2 pi. That will be the coterminal. Now, what will be the k? Which k can we use? If you look at this, you can continue. For example, you can remove, we can take k to be, what is the half of this one? Yeah, we can take k to be maybe like 109, right? And if you take k to be 109, it will just be this minus itself. So which will be just 0, right? And we know that 0 is less than 360. So it means this is the same thing as tan 0 pi, actually. It's just going to be tan 0. This is the same thing as tan 0 degree plus 4 sine. All right. What is sine 180? Okay, let me just write this one again. And this is nothing but 5. This is like cosine pi all squared. But what is tan 0? Here we have tan 0. Tan 0 is just going to be what? What is tan 0? Look at tan 0. It's just going to be sine 0 over what? Cosine 0. But sine 0 is 0, while cosine 0 is 1. So tan 0 is just 0. Then plus, this will be 4 times sine 180 is minus 1 plus 5 cosine 180. What is cosine 180? No, so sorry, sine 180 is 0, right? Sine 180 is 0. So let's go back here to check this one. So where is 180 degree? This is 180 degree. So sine 180 is 0, but cosine 180 is minus 1. All right, so here we will have minus 1 whole square. And this is nothing but what? Everything says it's going to be 0, so we just have 0 plus 0 plus 5, which is 5. Right. Okay. Then what else again? For this one, this is 4 cosec 270. So cosec 270 is what? We know that cosec 270 degree is just going to be 1 over what? Sine 270 degree. Now, what is sine 270 degree? We can see from here. This is sine 270 degrees. Sine 270 degree is what? Is minus 1. Okay? So what that means is that this will just be equals to minus 1 as well. So here is going to be times minus 1, then minus 6 sine 90. Sine 90 is 1, right? Minus 5. This is going to be tan what? Tan 360. Then you square it, right? But we know that tan 360 degree is what? Is sine 360 degree over cosine 360 degree. But sine 360 is 0, while cosine 360 is 1. So tan 360 is equals to 0. So this is also 0. That means you will have minus 4 here, and minus 6, then minus 0. So everything is minus 10. All right. Okay. So this is how to use these quadrantals, evaluation of quadrantals. Right. Thank you for watching.